Good morning, everyone. My name is Liz Somerville. I am a senior meteorologist here at the National Weather Service in Corpus Christi. So today, some of the things we're going to talk about are the National Weather Service itself and some of our marine hazards. We're going to talk about some instruments and severe weather information, marine weather phenomenon, storm spotter techniques, how to report to us, and about beach safety. So about the Weather Service and some of our marine hazards. Let's start with the Weather Service. We have 122 weather forecast offices, which we call WFOs. We have 13 river forecast centers all over the country, and we have 9 national centers. They kind of go all over the country. We have the Storm Prediction Center is one you guys are probably pretty familiar with, the Hurricane Center down in Miami. Up in Washington, D.C. is the Weather Prediction Center, and we also have the Ocean Prediction Center there. We have the Aviation Weather Center, and we also have our numerical weather folks, or weather prediction folks, so they help us with modeling and things like that. Here in Corpus Christi, we are responsible for 15 counties and the Gulf of Mexico out to 60 nautical miles. We're pretty much going to focus on the Gulf of Mexico part. What we do, which 24 hours a day, 7 days a week, 365. We issue warnings for tornadoes, severe storms, floods, hurricanes, coastal flooding, you name it. If it's a weather hazard, we are trying to watch for it. So why do we need spotters? We have all of this other stuff. Well, we need spotters because they provide detailed real-time reports of severe weather. You guys would be our eyes in the field, basically. You are able to give communities downstream time to prepare, and you're trained to identify severe storms and report to us, so that way we know what's happening out there. We do have the radar, so a lot of folks will ask us, well, why do you even need the spotters, even though you're saying you need these eyes on the ground? And it is our primary tool for issuing warnings. But the Earth is curved and the radar beam is straight. So as you get further away from the radar, the higher in the storm it is. So if we're out in, say, Laredo from our radar here in Corpus, we're obviously a lot higher off of the ground than we would be if we had the radar beam, you know, if we're looking for something in Corpus. Another thing that we have with the radar is there's the cone of silence. Just directly above the radar doesn't shoot a beam that goes directly above. So we do get a hole where the radar is actually at. So we can't see anything in that spot. And if you look at this graphic here, you can kind of see in the center how there's just kind of a gap in the coverage there. Again, this is an image of it, just kind of a 3D image of it, where you can kind of see a cross section that shows from the radar. You know, we can't see anything above it. It's just, there's nothing right at the radar. And then we go way up. So as we get further out, we get pretty high up into the atmosphere. So we're not able to see what's actually reaching the surface. One of the things we want to talk about today now is the South Texas marine threats. Those are wind and waves. Anything that makes your boat rock is something that we're going to talk about that is a threat. Severe weather and water spouts, sea fog, lightning, rip currents, coastal flooding, and hurricanes. So we do issue marine watches. We have gale watches, storm watches, and hurricanes, and force wind watches. Basically, a watch means be prepared. The conditions are favorable for a weather event to occur. So you're going to need to pay attention and be ready to act. For a warning, we do gale, storm, and hurricane force wind warnings. That is not the same as a hurricane, because the hurricane force is actually not tropical. When we have tropical warnings, we do tropical storm and hurricane warnings. We actually use the National Hurricane Center's information for those. For a warning, the threat is imminent or occurring. We actually want you to seek shelter immediately. It's take action now. We do have advisories as well. We do ashfall advisories, although we really don't do them much here because they have to do with volcanoes. Dense fog advisories, we tend to get a lot of those over the waters with 1 nautical mile or less. Dense smoke, small craft advisories, we currently have one of those today with the wind speeds or frequent gusts 20 to 33 knots and seas or waves 7 feet or greater. And we can issue them small craft advisories for hazardous sea, although we generally just keep it as a small craft advisory. The product appears similar, it's the same really. We work with the Storm Prediction Center for severe weather outlooks. In this case, we're showing moderate risk up here, hazards and things like that. This graphic just kind of shows what the storm prediction is able to put out. You will see if you kind of look down toward Corpus at the south there, the southern or the bottom portion of it, it does actually cover into the waters. You don't see it very often down here, but we do get severe weather outlooks over the waters. We do have multiple categories. So general thunder, we're really not expecting these severe storms. A marginal, there's the potential for some severe storms. They're isolated. Slight storms, again, isolated to scattered. And as we go up, we tend to just increase the coverage. So scattered to numerous, numerous to severe, or numerous severe storms, and then numerous severe storms expected again. The way that is broken down is that as we get to a 4 and a 5, those are much more likely to happen. We work with the Storm Prediction Center by looking at their severe weather outlooks for days 1 through 8. In 1 through 3, there's a lot more detail. And then we have severe thunderstorms and tornado watches, which we actually can get over the waters. And that is issued 1 to 2 hours before the storms develop, ideally. And then warnings, generally 30 to 60 minutes long. We try to get those out 10 to 15 minutes before severe weather impacts. And sometimes over the waters, we may issue it a little earlier just so that folks have a chance to get out of the way of it. It's a lot harder for mariners to move out of the way. So again, a watch versus a warning. Watch means be prepared. The conditions are favorable. You have all of the ingredients to make a severe storm. A warning means that the severe storm has formed or is just about to form. That could mean, basically if you're baking a cake, watch means you have the ingredients. The warning is the cake is baked. So here are some weather concepts, severe storms and instruments and observations. For our thunderstorm ingredients, we need instability, moisture, and lift. That's all we need. So instability, it's just the measure of the air parcel's tendency to move upward. The greater that potential is, the greater potential for severe storms. Moisture, our main source of moisture is generally the Gulf of Mexico, although we do get Pacific moisture, particularly in monsoon season sort of. We don't really get the monsoonal moisture as much, but we do see definitely get some Pacific moisture then. Winds will get low level moisture inland, and that kind of helps get convection kicking off. The main thing we need, though, we can have all the moisture and all the instability, but if we don't have anything to make it lift, there's not a whole lot that's going to go on. So large scale things would be like fronts and dry lines, which we've been dealing with for the last several days, and small scale boundaries. In the summer, mostly we'll see sea breezes, some outflows, that kind of thing. For general thunderstorms, the life cycle is basically towering cumulus. There's really not much rain. The storm is building. It then becomes mature and the intensity increases and lightning becomes the most intense and tornado potential could increase. And then once it dissipates, that's when the intensity decreases and you're more likely to get a potential for downburst because you're seeing the storm sort of rain itself out in more downward motion. For severe thunderstorms, the main ingredients are instability, moisture, lift, and wind shear. So the increased shear causes some rotation in the storms. It tilts the storm. It allows the updraft to twist a bit and the storm strengthen and exist for longer periods of time because the downdraft will fall far away from the storm. So common types of severe thunderstorms, we have single cells, the usual brief, generally weak Updraft, not severe usually. We get a lot of those. Sometimes you'll hear us call them pop-up showers or popcorn showers. Multicellular clusters or lines. Most of our severe threat does come from lines. Moderate updraft, wind and hail are generally the greatest threats in those. And then supercellular ones. Those are intense. They have very intense updraft. They're almost always severe. Wind, hail, and tornadoes are possible. Squall lines are what we generally see here, as I mentioned earlier. Moderate to strong wind shear, you get this linear line appearance on the radar, so it looks like a line. And often we see a shelf cloud on the leading edge. They're usually long-lived, and they can be severe, especially, they don't even have to be severe along the whole thing, just even sections of it could be severe. They can produce hail and widespread damaging winds, and sometimes you can see a tornado in those. When we get just these radar images kind of show us, on the left we see that there's a little kind of appendage that comes off of the line there in the front. That is where we would look to see if there is a tornado in there. Generally, that's where it can be produced. On the right, we see kind of a bowing segment where the pink is, and you see this kind of rear inflow notch. So what happens is the strong winds cause the bow to form, and that indicates to us that there are intense straight line winds. That's a bow echo. For supercells, they have moderate to strong wind shear, and they're long-lived. There's a mesocyclone in there, which just means that the storm itself is rotating. Usually they're isolated, but they can be embedded in lines. They produce large hail, damaging wind, tornadoes, and they are identified by a hook on the radar. The interesting thing is you can see the hook on the radar and still not have a tornado. So just because you see a hook doesn't mean there's a tornado. You kind of have to look to see the velocities as well as some other features to see if it's something that you think is going to be tornadic. These can pose a significant threat to life and property. So usually, just kind of the anatomy of the supercell, you'll see that the storm motion kind of moves to the northeast. We have a forward flank downdraft, that's where it's going to be moving out of the storm itself, and a rear flank downdraft, kind of in the back. That has to do with the rotation of the storm. You get an updraft that brings warmer air into the storm itself, which causes us to just kind of fuel itself over and over again. We get warm lifted air, and then it kind of cools, and we get all this just action that kind of moves through. So what we see there is in the center, kind of near the hook, we see that's where the storms would be generally the most intense. We'll get some hail just outside of the main updraft there. And what's happening is it's kind of the reason why it's pushing toward the forward flank is that it's actually moving out of the downdraft there. So it kind of tilts over there and falls out of that forward flank downdraft. That area in there where the hook is, that is generally where you would see a tornado. So some of the common cloud features with severe thunderstorms. The most important thing you can learn is to tell the difference between updraft clouds and downdraft clouds. It's also important for spotters to use clouds to identify supercell storm features and clouds that may indicate tornadoes or waterspouts are forming. In updraft, the air is moving upwards. It's kind of like a vacuum cleaner for heat and humidity. There's not rain in the updraft. If there's a tornado, it occurs there. It only takes up 10 to 20% of the mature storm, so it's pretty small. For a downdraft, the air is moving toward the grounds, and that's sort of the outflow of the storm. This is where all of the rain and hail falls. You don't get tornadoes in the downdraft. You might experience straight line winds, but you don't get tornadoes there. And that makes up most of the mature storm, 80 to 90%. So if you look, you can kind of see in this graphic how we've got updrafts moving up. We see the flanking line behind, mammatus clouds up at the very top. You'll see cold downdrafts where the heavy rain and the winds tend to be, there will be a gust front at the front of that where the downdraft is. You could see a shelf cloud at the beginning of that. For a wall cloud, you'd see it at the back of the storm. And that's where underneath the warm updraft. So some clouds that we see, turkey towers, cumulus congestus, sorry. These are vertically developing clouds. Usually there means that there's a weakening of an inversion. You might get some more thunderstorms later on in the day. If you see a strong updraft, that's when you start to know that the storms are strengthening. The clouds grow and eventually spread out horizontally. If you see this here, where you see this kind of overshooting top, where everything is flattened out and then all of a sudden there's this cloud that kind of pokes above it, that's usually a good indication that a storm is strong or severe. This usually forms when the momentum of the updraft is so strong, it goes through the top of the equilibrium level, where the stable layer is above the storm. We get a tilted rotating updraft. You can kind of see it in this image here where the arrow is. It indicates that there's wind shear within the storm, and that's where your mesocyclone is. It's usually strongest in the mid-levels. For a wall cloud, you're going to look for the lowering and rotating base beneath a rain-free updraft. Rotation and lowering should remain persistent. You'll see lowering clouds periodically in some of these storms, but if it's not persistent, it's not a wall cloud, generally. It's directly beneath the mesocyclone, and tornadoes may form beneath the wall cloud. A funnel cloud, we see those kind of a lot around here. It's not in contact with the ground or the water. A rotating funnel can be a sign of increasing tornado potential within the storm. We get mesocyclones and supercells. These are just really pretty pictures of them. They kind of can look like alien spaceships. Sometimes they call it the mothership. For hail shafts, when you look through this, you'll see that there's a rain-free base on one side. That is where the updraft is. If you look further into the storm, you'll see where it's tilted, that we get larger hail closer to the storm, and you can kind of see through it. And then the smaller hail, and then rain. This is because the winds can carry this rain further away from the storm than it can carry the large hail away. A flanking line is usually an organized zone of cumulus clouds connected to and extending outward from the strong to a severe thunderstorm. There's generally not any severe weather in those. You might see some rain, but generally not. Mammatus clouds. These mostly just look really cool. They're sinking air, so it kind of looks like pouches. They can accompany severe thunderstorms, but they don't produce any severe weather there. Downbursts. We do get these around here. If you look down at the bottom, we have some images of what it can look like on radar. A microburst is just a downburst with a diameter of less than 2.5 miles. They're generally pretty short-lived, 2 to 5 minutes, and winds can go up to 168 miles per hour. A macroburst means it's bigger than 2.5 miles. It generally lasts 5 to 20 minutes, and winds can go up to 135 miles per hour. So if you look at the image on the right, you can see that this is the initial stage. It's when the downburst starts to descend from the cloud base. At the impact stage, the strongest winds are at the surface, and this is the greatest danger to aviation. In this case, you can see it has what's called a rain foot, and the arrows sort of indicate that. You can see where the clouds have dropped, and it's dropping rain and wind and air, and it just hits the ground and it has to go somewhere, so it goes out in all directions. For a shelf cloud, we can see those at the front side of a supercell or on the front side of a line of storms. And this is just the leading edge of the gust front. It points away from the rain. So you'll see that the clouds kind of point away from it. Rain will be behind the point. For outflow winds, we get these a lot with the collapsing thunderstorms, and even from some of the linear storms that we get. Air flows out and away from the storm. And this is usually colder than the regular temperature, than the temperature around you. So sometimes you'll feel that cold blast of air. That's the air from the actual storm falling down and kind of coming down from higher levels and pushing out on the ground. How do we define severe thunderstorms? Well, large hail greater than an inch, damaging winds around 58 miles per hour or greater. Any flash flooding, we could call that severe, although we do have flood warnings for those. If there's a tornado or water spout, it is considered a severe thunderstorm. And marine winds greater than 34 knots are severe. While we are talking mostly about marine weather in this, we're going to continue talking a little bit about land, because especially with the tornadoes, water spouts can move on shore. So that is part of why it applies here. All of this information also applies over the water. But once we get into the tornadoes and what they mean, generally this is just going to apply if the water spout moves on shore. Most of our tornadoes are weak, EF0 to EF1 down here in South Texas. They don't last very long. A lot of them are not detected by radar, and it's really difficult for us to get spotter confirmation. Most are unreported. And most of the time those are from water spouts moving on shore. Less likely for us, especially over the waters, are the stronger tornadoes in EF2 or EF3. Those are less likely over South Texas. 30% of our tornadoes are EF2 or EF3. They can last a little longer, 15 minutes to an hour, with some pretty higher wind speeds. They're a lot more easily identified on radar, and we do get good spotter confirmation on those for most of the time. Now for EF4s and EF5s, the likelihood of us seeing those from a water spout are slim to none. Really, as it is, 3% of South Texas tornadoes have been EF4 to EF5s historically. They can last 1 to 2 hours. Wind speeds can be over 200 miles per hour, and they're generally really pretty easily identified on radar. Most are reported. One of the tools that we use here is, of course, again, the radar. Now, our radar operates 24/7, 365. What we do detect with the radar is just particles in the air. We don't see anything on the ground. Our scans are not low enough to reach the ground, although we are getting a lower scan, which is very exciting to all of us, but it still won't reach the ground. And we are able to update our scans every 1 to 2 minutes, but we still need those ground truths because we still can't see the ground. The radar operates by transmitting a pulse. We get a vertical pulse and a horizontal pulse because we have a dual polarization in our radar. This helps us determine how much is in the atmosphere and what shape is it, which helps us figure out, is it ice, is it hail, is it rain? It can really help us determine what kind of precipitation is falling. We look at the reflectivity, and this is something that you guys can look at online, on apps. More intense storms are shown by warmer colors. So white and pink usually indicate hail. Reds, oranges, yellows are usually more intense rain. That does not mean it's severe if it's red. It just means that there's heavy rain in that area. Cooler colors like the greens and the blues indicate lighter rainfall. For velocity from the radar. So the red moves away and the greens tend to move toward the radar. If they're next to each other, we see a bit of a spin. Could be something that is tornadic, but we have to confirm that. And sometimes we see these broader motions that appear to be rotation, but it's such a broad rotation that it's not really something that we're super concerned about. We would be continuing to watch it to make sure it didn't spin up tighter or become an issue. But that does happen, particularly in some of these stronger lines that we get. For us, we get GO16 satellite. We get 1 minute imagery available. This actually does get ingested to weather models, which helps us get more accurate forecasts. The GO16 is geosynchronous, so we can kind of point it at a specific area and leave it. It's obviously up in space, but we're very fortunate at the quality of it and the resolution. We do weather balloon observations. We do those in our office twice a day. This video here is just the it's special sounding that we did during Hurricane Nicholas, just so you can kind of get an idea of what we have to do at times. You can hear the wind is pretty strong there. In this case, we often do a two-person launch because it is tricky to get the sonde released at the same time as the balloon, because you have to kind of run after it sometimes so it doesn't hit the ground. If it hits the ground, then we generally don't get much observation after that. We also get surface observations from ASOS sites, AWAS sites. They're automatic, or just buoys, things like that. So we're very, we try to get as many observations as we can. So moving on to marine weather and phenomena. This is the part that I think we're most interested in. We get water spouts, but what is a water spout? It's basically a tornado over the water. It must be a rotating column of air that touches the clouds and the water. There are two basic types of water spouts. There's the supercellular ones. They're stronger. They're pretty rare along the Gulf Coast, but we are more likely to see them in tropical cyclones. And the non-supercell. Those are more common and generally weaker. We see these a lot more commonly along our coastline. There are different stages of water spouts. The first stage is the dark spot. So you'll see a prominent kind of a light colored disc on the sea surface. It's surrounded by a dark patch. Generally, this is only viewable from the air. You may see a small funnel cloud above the dark spot, but the dark spot actually indicates that there is a complete vortex from the cloud base to the sea surface. For the second phase, we see the water spout, or the spiral pattern of the water spout. This is the primary growth phase. You'll see alternating dark and light colored bands spiraling on the water surface. Again, this is best viewed from the air as well. And again, you could see a funnel cloud on top again, but you probably won't see the column all the way up and down. For the third stage, we have the spray ring stage. This is a concentrated spray ring, so you can see it's on the water. And there's a dark spot on the water, and then you'll see the lengthening funnel cloud from above. This means that in order to get sea spray off the surface, that means the winds are at least 43 knots, according to the U.S. Navy Hurricane Reconnaissance Manual. For the fourth stage, it's mature. That's generally when you can see the spray vortex. It's at the maximum intensity. You can see the column from the top of from the base of the clouds to the water. There are still some times when you won't see the whole funnel or the whole cloud, but this is its maximum length and diameter that you're going to see. And then we have the decaying stage, and that's when we're going to start to see the funnel clouds or the water spout just sort of dissipate and start to go away. They're really tough to catch on radar. If you look, you can kind of see, so we're seeing, this was an image of a water spout. You can see that there's spray on the water and that there is indeed a funnel. But if you look at radar, it's very tricky to see. You can see that there is a little inflow notch or a little appendage there on that line, and a slight little rotation where you see the red with the kind of green in the center. That's a really hard thing to catch on radar when you're looking at a large area of it. Another one that we have here from near Port Lavaca, again, water spout clearly visible to the naked eye out there. However, we really can't see it on radar. If you look at the radar imagery, there's not a whole lot there going on. And even in reflectivity, there's a slight little inflow there. And it doesn't really look like a whole lot of rotation, just sort of an area of increased winds. So they can be very difficult for us to catch, which is part of why we need you guys to be storm spotters. In this case, most of our waterspouts do come from squall lines. In that case, we see a squall line. In this case, we have a 2018 squall line. It went through and it produced 3 tornadoes, which were waterspouts that came ashore. In Seadrift, it was an EF1, so a relatively strong one. You can see on reflectivity, it's very difficult to see, but there on the velocity, it was a lot easier to see. For the one at Holiday Beach, it was an EF0. We're pretty zoomed in there to see it because it was very weak. You can see that there was definitely a little inflow notch there and a little bowing segment of the line, and that there was rotation. But we had to zoom in pretty close to see this because it's just such a weak spot that it was hard to see. And then the last one that we're going to talk about is the one in Woodsboro. If you look, you can see in the reflectivity, it's very difficult to see. There's a little bit of a line there, a little bit of flow, a little notch there. And again, in the velocity, it's even difficult to tell. You can see some increased velocities, but if you look just to the north, it looks like there's some up there too. What you have to look for is that red and green next to each other. The next phenomena we're going to talk about are wake lows. Wake lows can occur behind the squall lines. Winds often reach 26 to 43 knots, but can reach well over 50 knots in some cases. They're not handled well by model data. Quick development, small scale, it's just very tricky for us for the models to catch a wake low. So a wake low is basically associated with a pressure fall that is maximized on the trailing edge of the stratiform precip behind the squall line. So once the main part of the squall line comes through, and then you get just sort of rain, that behind that rain is where you're going to see where a wake low is most likely to develop and really cause some bigger problems for us when we can get the rear inflow jet. It tends to get caught underneath an inversion and push down through there. And that's when we see this stronger winds that come along with a wake low. So an example here, this is actually from New Orleans, in Louisiana there. You can see on the reflectivity, there's not a whole lot going on in this reflectivity. It's, the signals are very subtle and it doesn't look like there's a whole lot. But then you look over in velocity and you see that these winds are very much increased. This is because it's behind the rainfall. The majority of the rear inflow jet is caught beneath the inversion behind the rain. So just keep an eye on those when you're looking at things. It's not always the reflectivity that you need to be looking for. And then it's the storm from, and yes, the orientation is a little bit different. It is a north on the left side and south on the right. And if you look in the very back, you can see there's a scale that's kind of showing almost a 3D version of it to kind of show us how high up the storm came. It sort of depicts the area, though, of where we're looking at the stronger winds to form this wake low. The line is bowing. The precipitation behind it is diminishing. And where the arrow is kind of where we're going to see a wake low develop, and then the winds start pushing forwards. During this time, you kind of see. So these are observations that were taken at the time that this wake low passed over these observation sites. So what you'll see here is that you can actually see the pressure just drop right behind. It goes, it increases, and then it drops in both cases. When the pressure increases and drops, you can see the change in the wind's speed and even some in the direction. The wind speeds increase dramatically and our wind gusts increase. In this case, up to almost 60 miles per hour, which is definitely a severe storm. We also think that we know that these measured winds kind of peaked near 48 knots. There were higher gusts, and in some cases they think that there were some winds that were near 75 miles per hour that were a little further away that may have been associated with it. So we definitely can see some stronger winds than just 48 knots, which is where we're severe. The winds rapidly develop behind the squall line. Really, when most people believe the worst was over, which is part of why a wave cloud can be so dangerous. The worst part of the storm is already past. You think the danger is done. In this case, it resulted in a fatal marine accident when a lift boat capsized. This can happen along the Gulf Coast anytime we have a squall line. Generally, it isn't super common, but it does happen. So it is something that we watch for. And if you are out storm spotting or out on a boat, it's something we really want you to pay attention to, because just because it seems the danger is over doesn't mean it is. Another issue we have is sea fog. We're all pretty familiar with that. How does it form? Well, we're used to fog forming over land with the light winds. Dry air aloft, moist air at the surface. The sea fog is a little different. It's more likely to form for us along the middle Texas coast when warmer air moves across the shelf waters near our shores where there's cooler sea surface temperatures. We get some condensation, and that's when we're going to see sea fog development. So the winds actually need to be just a little higher for us to get sea fog development, because otherwise, if the winds are just barely moving, it has time for the temperatures to moderate and we're less likely to get sea fog. So it looks like it's going to be easy because you think, oh, warm air over cold water, sure. But it is deceptively difficult, and it can hang on longer than you expect. This is just some satellite imagery of what sea fog can look at like for us. We're looking at nighttime microphysics. So we're looking over on the left side, we'll see kind of the pinky purples. We're looking there to see, well, is there fog across there? And in this case, there is. You can kind of see it in the lighter colors along the coast. And again, over on the right side, we have night fog. It's another GOES 16 product that we also use to monitor for fog. So let's move into some storm spotting techniques. So spotting problems, water spouts may be partially invisible and they may be obscured by rain. So if you look, you can see these two images. You can't see the water spout really. And you can in either of these images, particularly the one with the rainbow in it, you really can't see it. It is there, but it's difficult to see. Another thing is that a lot of things look a lot alike. A water spout, it could have a smooth appearance. It should be touching the water and rotating. For a funnel cloud, it's a smooth appearance. It's not touching the water, but it's also rotating. And with funnel clouds, they're a little tricky because we can get them even when we're not expecting severe weather. Enough tropical moisture and shear values and winds aloft, and we'll see funnel clouds. We also get scud. It's basically just a scary looking cloud. It's usually ragged in appearance. It can show motion, but it's not rotating. So some of the spotting strategies, again, you're going to find the updraft and the downdraft. And again, the updraft is where you're going to see the most vertical development. Find the most favorable spot for severe weather if you're going out to look for it. One of the things you can do on the water is follow the birds. Birds will rise and fall with the updrafts. They ride those winds. So you can look and see if the birds are flying along and then they start to move up, likely they're in an updraft. Some of the spotting strategies: be very aware of your surroundings. You need to know what direction the storm's moving in. You need to keep a safe distance and have an escape plan. We don't advise storm chasing over the waters. You just don't have the speed you need to get away from the storm like that. You really just need to keep a safe distance away from the storm. In this case, this storm spotter, who is a forecaster at our office, it has obviously stayed far enough away to be safe. He doesn't need to be in the storm to see the storm. In fact, you can't see it when you're in it. nighttime spotting is definitely not recommended. We don't want you going out to the beach to look for water spouts or driving around looking for severe weather at night. It's just not safe. You can't see what's happening. So how are you going to make reports to us? If you're interested in that, if you're interested in SKYWARN, we're hoping you'll give us some reports. First, you can always give us a call or get on social media. You want to be specific. What did you see? When did you see it? And where did you see it? And when we say where, we really like specifics. You saw it at the corner of this street and this street in this town. Very specific for us. It makes it a little easier for us to know, okay, we were looking at it on radar, we saw this here, this is what they saw, so that way we can be more accurate further down the line. Free to give us a call. We have a toll-free number and we have a direct line. Please give us a call anytime. That direct line rings right in our office in operations. So you will get a forecaster if you call that number. You can always update it on social media. Twitter and Facebook at NWS Corpus. Somebody's always watching that. You can send reports and pictures, send us a direct message, do the hashtag of CC Spotter, and we will search that anytime we think something's happening. We really want wind, hail, tornado, wall and funnel clouds, flooding, any of those reports. That's really important to us so that we can help you guys. And honestly, if you are on the waters and you see higher wave heights than are expected, if you see some shifty winds or things like that, we also love those reports as well. MPing. You can even use it over the waters to a point. It's available on iOS and Android. It sends the reports directly to our office. It's anonymous. It's user-friendly. You literally download an app and just poke where you need to be and put the report time. It's very simple. There are ways to get NWS alerts as well. So you always want to be able to receive warnings. If you're out on a boat, you need to have a weather radio. It reaches much further than some of the other signals that you're going to get. Conditions can change so rapidly. You really do need to be very cautious about those things. On your phone, you can get tornadoes, severe thunderstorm warnings, flash flooding, extreme wind, hurricane, tsunami, storm surge, and winter weather alerts. So we'll see some of those, and those come across often as the wireless emergency alerts. A lot of people like to turn those off, but we're asking you not to, because those can really indicate hazardous weather. And we have changed a few things so that for a tornado warning, it will always alert. For a flash flood warning, we have actually changed it so it doesn't alert for every single flash flood. It will alert if it's a significant flash flood. And for severe thunderstorm warnings, when hail is larger than baseballs or winds greater than 80 miles per hour, that's when it will trigger via on your smartphone. So now I just kind of want to touch on some beach safety. Obviously, we need to know our flag conditions. Those do not necessarily correlate to the rip current risk for the day. There can be red flag when we have a low rip current risk. There can be there's many other factors to the flag system than just those issues. One of the first things I'll talk about is lightning safety, because that applies land or sea. A bolt of lightning measures about 50,000 degrees Fahrenheit. They always say it strikes the tallest object, but that's not always true. It can strike the smallest objects. It's going to find the path of least resistance. And it can strike the same place twice. It can strike more than 10 miles away from the storm. That's where we get the phrase out of the blue. If you hear thunder, you're close enough to be struck by lightning. So if you're outdoors, please go indoors. You need to find shelter in a building or a hardtop vehicle. If you're out camping on the beach, a tent is not going to help you. And you'd want to wait 30 minutes after you hear thunder to resume any activities. If you're out on a boat, obviously thunderstorms pose a hazard to mariners. They bring dangerous winds, lightnings. If you see a storm, you should probably head to land as soon as you can. The next thing I want to talk about is some rip current safety. This is one of the things that we really hit hard in our office and really along the Texas coast. Rip currents are just fast flowing channels of water that extend from close to the shoreline, through the surf, and past the breaking waves. They can reach speeds faster than an Olympic swimmer. They're not trying to pull you under, but they will pull you out, and that can be very scary. How do we spot one? Well, if you notice in this image, there's all these waves breaking, but right there next to that jetty, we don't see any waves breaking. That is one of the places we're going to see a rip current. In this case, again, breaking waves, and then in the spots that look less like there's breaking waves, that's where we're seeing a rip current. A lot of times the water will push a little bit differently on the shore. One of the things that's really dangerous is you look there and you think, well, it's less wavy there. That's where I want to swim. And that is actually the worst choice, because that is where the rip current is most likely located. Rip currents are not always perpendicular to the shore. They look like they're going to be, but they can be slightly angled, particularly along our coastline. So if you do get caught in a rip current, they're not trying to pull you under. So trying to swim against the current is only going to make you tired. So you want to just relax. Try to swim along the shoreline. Even if it's at an angle, you're going to still pull free from that rip current if you can swim parallel to the shore. When you're free of it, then you swim at an angle away from the current toward the shore. If you feel like you can't reach the shore, just relax, float, face the shore, call or wave for help. If at all possible, you really only want to swim at beaches with lifeguards. If you do swim on a beach without a lifeguard, don't swim alone. Take a friend, have the person take a cell phone so they can call 911 for help. And when you're in doubt, don't go out. If you think there's rip currents and you're nervous about it, don't go out in the water. Tornado safety. Again, while we're not going to see a whole lot of these with what we're doing for the marine stuff, if a waterspout were to come on shore, you do want to be more careful. You want to seek shelter in hallways or interior rooms. Avoid the large open areas. Same with your vehicle. If you are driving along and a waterspout happens to come on shore, you're going to want to find reinforced shelter. There's no point of putting yourself in harm's way. Just get your vehicle to get yourself to a safe place in a reinforced shelter. For high surf, that's another issue that we have here. We do have rip current fatalities here, but we also have high surf fatalities. Fortunately, we don't have a lot of either. But these are important things to know about. Waves are constantly changing, so you need to listen to them. You need to watch them. You're going to want to stay back further than you think in case the waves do push further in. And you want to know the local forecast. When we say the surf height, we are saying the average of the top third of the wave heights. So waves could definitely, in this case, we have a surf height of 3 to 4 feet. And that means that we could see surf or wave heights that go up 5 feet. And that's not unreasonable to assume. So we need to be cautious with what the waves are doing. In a stronger event where we see higher winds, avoid going out on those jetties. The waves can push up over the jetties and wash you off and into the water, where you just won't be able to get out because the waves are too strong. Water is incredibly powerful, and we tend to forget that because it is also beautiful. So before your storms, you need to have a safe place from tornadoes. That's at home, at the beach, wherever you are. You need to have a plan, know your plan, and practice your plan. If you are at the beach and a waterspout moves ashore, what are you planning on doing? If you see a waterspout and it's coming towards you, which would often look like it's just standing still, what are you going to do? Where are you going to go? So you want to find a safe place. Know where to go. For SKYWARN, we have a SKYWARN spotter check-in. This shows spotters who check in during SKYWARN Recognition Day. Obviously, we have a large gap out west across the brush country, so we really would love to have some more spotters in that area. And if you look along the coast, we don't have a ton as we move toward the north. We would really love some more spotters up toward the north as well along the coast. So that pretty much concludes what we're talking about today. SKYWARN certificates, if you want your SKYWARN certificate, you can just enter your first and last name, enter this password, and create the certificate. It is not required for you to have it, and it is just something if you call us and say, hey, I went to the SKYWARN and I want to make a report, we're going to believe you. If you're not from South Texas and you're still on here, or even if you're just traveling, you can get in touch with local contacts by going to the Storm Ready contact page. So there is a link at the bottom there. You can kind of see it, and these places will tell you where you want to, who you want to reach out to or talk to if you need to talk to somebody about becoming maybe more, doing more SKYWARN for a specific area. However, should you want to make a report and you're in a different area, you can call that local office and give them a report. I'm sure they'd be happy to receive it. So I really appreciate your time today. And if you guys have any questions, please feel free to let me know. You can shoot me an email or call, whatever you'd like to do. If you want to put a question into the chat, then I will answer that. And I see that there is one in there, and we will have slides made for you guys. I can email those out, or we can send those out if you'd like to email. There's a Tyler Castillo, who is one of our meteorologists who's kind of running this program. He can send you a printed, certificate or those slides. I can also do that if you want to shoot me an email. My email is liz.somerville, and that's SOMMERVILLE @NOAA.gov, and I'd be happy to make you a slide deck available as well. If there's any other questions, I am certainly all ears and would just be happy to answer anything I can for you. All right. Well, you guys have a wonderful day, and I sure appreciate your time. And we appreciate the interest you guys are taking in the weather around here. Please let us know if there's anything you can do. Again, that phone number we gave earlier is available to call the office at any time. Thanks so much, guys. We appreciate it. Have a good day.